less than 12 radian cents. Our aim today will be let's convert between degrees and radians. Right, both degrees and radians can be used to measure the central angle, or really any angle for that matter, and also the length of an arc. 12.1, which one doesn't belong, angle measures. So which one doesn't belong? So take a look at A, B, C, and D, and come up with a convincing reason why that particular circle out of the 4 does not belong with the rest. All right, I look forward to reading those. So what I'm going to do really quickly is just do a review of radians and sort of familiarize you with some stuff going on here. So in this first one, A, we're given a circle with a radius of 1 centimeter and an arc length of pi over 2 centimeters. It looks like a right angle, and in this case, that is exactly what it is. So anytime you have a radius where the length is 1, and they also give you the length of the arc, if that radius is 1, that means that it's going to be a really easy conversion to radians, right? So we talked about in last lesson, radians are equal to the length of the arc divided by the radius. So let me just make sure I see what that represents. Length of arc divided by the radius. How many radii could fit in that arc? That is what a radian is. How many radii can I fit in that length of an arc? So here is very simple. We've got pi over 2 over 1, which is really just pi over 2. So that's the radian measure of this angle. Let's say I want to get degrees. I know that in total, there are 2 pi radians all the way around a circle. I know in degrees, there are normally 360 degrees around a circle. I don't know how many degrees might be in pi over 2 unless I have them memorized. So this is how I would quickly convert. Cross multiply. Pi over 2 times 360, and then 2 pi times x. First thing you're going to do here, you see pi on both sides of your equation, cancel them out. 360 divided by 2 is 180. 2 times x is 2x. Trying to get x alone, divide by 2. We'll get 90 equals to x. So that's a good one to remember. Pi over 2 radians equals 90 degrees. All right. B, they've already given us the radians, 3 pi over 2. So if I wanted to save myself some time, I see that pi over 2 is equal to 90, and this is 3 pi over 2. So I've just multiplied my radians by 3. So I can do the same thing and multiply my degrees by 3. We get that that's 270 degrees. All right, here we've got 51.5 degrees. I don't have a radius measure, I don't have an arc length, however, I can still find radians. I know that in total, I've got 360 degrees. I don't know my number of radians, but I know in total, I have 2 pi radians in a circle. Again, we cross multiply. 2 pi times 51.5 is equal to 360x. 2 times 51.5 is just going to be, what is that, 103? 103 pi, equal to 360x. Divide both sides by 360 to get x alone. It's not pretty. I'm pretty sure that's the most reduced a fraction can be, because 103 is not divisible by 3. But I can always check. To do that, I'm going to go 103 divided by 360. And that doesn't look like a very promising decimal, but let's see what kind of fraction we get. All right, it doesn't convert at all. That's the most reduced it can be. So that would be the number of radians are in 51.5 degrees. Those are a one-to-one correspondence. All right, now we've got 1 radian. Sometimes it's written as rad. That can be a little confusing. I wouldn't do that because I would think radical, but they couldn't fit it here, I guess. I would write radians. That's a good practice to have. So again, converting, we know we've got 1 radian. In total, there are 2 pi radians in a circle. I don't know the degrees, but there are 360 total degrees in a circle. Cross multiply. 1 times 360 is equal to 360. 2 pi times x is 2 pi x. Get x alone, divided by 2 pi, divided by 2 pi. And we are going to get 360 divided by 2, which is 180 over pi. Yeah. So that's sort of that's going to be our degrees. That's sort of a weird way to express degrees, though. Usually, if you're talking about degrees, you're going to want a decimal, not in terms of pi. When we have something in terms of pi, it usually implies that we're talking about radians. So I'm actually going to convert that to a decimal, even though it's an irrational number. So it's about equal to 57 point. That's 296. It's not exactly equal to that, but that's relatively close. When we talk about degrees, unfortunately, it's better to be a decimal than a representation with pi. All right, that is all for lesson 12.1.